Hello everyone, welcome on the next episode of our BIM for manufacturers and designers webinar series. If you're not familiar with our webinars, I definitely recommend you to check our website beamstreamer.com, where under the events section you can find the recordings from the previous episodes. If you're not familiar with the concept of our webinars, we're in general covering different aspects of BIM library management, BIM content management, mainly in the concept in the context of manufacturers, but not only. We're also covering the topics related to designers, to wholesalers, and in general the process information which are conviewed together with the 3D geometry of the libraries. And right now, our previous episode is already available for the recording is already available for replaying. We're covering the topic of let's say different way of preparing the BIM libraries and explaining the reasons why the designers don't want to use the manufacturer libraries. So if this is something that you might find interesting, then definitely navigate to beamstreamer.com. Under the events section, you can find the recording of that event. But let's get back to our current agenda. Today we'll talk about the generative design, what it is, why it is actually so important to think about it, especially nowadays, taking under consideration the current way how we're actually dealing with the construction projects. And as usual, if someone is actually revisiting our webinar, they know that in addition to the theory, we also like to share you with some real case scenarios, some demos, examples, and that's what we're about to do in the second part of the webinar, where we actually explain you different strategies of generating the design, and also show some examples, a real case and example. And for that part, I had invited one of our software engineers, who is also a bridge engineer, graduated construction university graduate, who is one of our lead generative design developer here at BIMstreamer, and Sagiton, of course, who is part of which owns the BIMstreamer brand. Ladies and gentlemen, I would like to welcome our today's guest, Andrzej Rudzki. Hello, Andrzej.
Hello, everybody.
Okay, so let's start with some intro. So at the beginning, I would give you some glimpse of the reason why the generative design, how the generative design actually is so important. What are the historical reasons behind that? I would actually somehow I would be inspired with this intro section with one of the interviews that I've seen of Anthony Heck, who is one of the co-founder of the Hyper platform. So some credits to Anthony here for this intro. But in general, we do have quite a huge history when it comes to the construction. I'm not sure whether some of you are familiar with the Napo Tower. This is actually the first ever construction that is known to the mankind. It's dated. No one exactly knows how long it is, but some scientists suspicious that it can be even older than before 3000 BC. So quite a lot. Of course, during that time, the evolution of the construction changed drastically, but it only emphasized the fact that the experience of the human civilization in this area is pretty big. Well, after all, we need to live somewhere. We need to have our homes. We need to have our block of flats. We need to have our offices, and so on and so forth. On the other hand, we do have also quite a huge experience when it comes to computation, because the first ever computer that was actually ever invented was also invented in the BC era. So I'm of course talking about the abacus, but if we consider that more seriously, then the tools which allows us to simplify the calculation, the computation, we're getting more and more advanced, especially on the edge of the 19th and 20th centuries, where especially after the invention of the transistor, we had this third industrial revolution, the emergence of the personal computer, so the PCs. In the later stage, we had this boom related with the mobile devices. Right now, everyone has a smartphone. Everyone has actually his or her own data control center in their pocket, which computing speed is probably better than lots of the mainframes from the 70s. So the history of the computation is also quite huge. We do have a quite astonishing history related also with the design. So even if we are getting back to the ages of Leonardo da Vinci, where the designers actually started their initial projects, initially on the drawing boards in the form of the 2D drawings, which was more like a projection of the idea of the 3D model, which was in the brain of the architect. Later on in the 70s, when there was this third industrial revolution I was telling you about, the tools slightly changed. They changed a bit. And instead of using the drawing box, we started using the computer-aided design software, so the CAD systems. And right now, we're going more into the direction of the BIM. I won't go into details when it comes to what's the BIM in details when it comes to that, because I'm guessing that you're already familiar with that. If not, then check our webinars. We're talking about that on plenty of episodes. But in general, what I would like to stress is that together with the evolution of the computation, together with the evolution of design, also there was a huge evolution of the various software that was invented to simplify the designers, the planner, the constructor, the investor, and the other stakeholders' role in the whole concept of the design process. However, all of these software were focused on creating everything from scratch. Always from scratch, from an empty project. And why can't we just generate the design? Why can't we just generate building? Why can't we just generate the projects? We have a huge history of construction civilization, huge history related with the computation and the design. And why we always have to create everything from scratch. And even in 70s, there was some sort of a concept on one of the US universities to came up with some generator for the hospitals, and they even make some running proof of concept. And it was in the 70s, but up until now, most of the software are actually focusing on creating everything from scratch. So let's focus on what are the realities when it comes to the current, let's say, the present time. So first of all, our computation power is stronger every day. Like I said before, our smartphones right now are more powerful when it comes to computation than the servers back in the 90s or 80s. Moreover, the knowledge related with coding, with software development, software engineering is getting more and more common. Lots of the things you can actually find out on YouTube or any other sources out there in the internet. And if you have some engineering background, you're able to do some basic coding and sometimes even more sophisticated, as in Andrzej's case. Moreover, we need to deliver the project which includes some more complex calculations. Because the projects are more complex. Here is the example, for instance, of the Museum of the Future in Dubai. I would say that several years back, that kind of construction would not be even possible to be achieved. Right now, it is. But as we took all of this factor under consideration, we see that in order to do that efficiently, when there is a huge time pressure, when there is and also a budget pressure from the investor side, it's very hard to do everything from scratch and in a manual way. That's why the idea is to actually be able to come up with some algorithm, which can be fed with some input data, and in the end allows us to give some results, automatically generated results, which later on we can somehow augment it, we can somehow fine-tune in an iterative way, and as a result has a solution which is first of all optimized, cost efficient, and from the time perspective also efficient. If we would be able to do that, just imagine what could that give to us as a result. So here are some example of utilization of that kind of generative approach. So for the manufacturers or for the investors, we're quite easy to prepare the offering. Let's just imagine that you are a prefabricate manufacturer or piping and fitting manufacturer, and someone comes to you and asks you to give you give him or her the quote for specific project. Usually you need to actually spend some design work on your side in order to come up with some project and later on prepare the bill of materials and the offer in the end. It might be time consuming. It can take your internal team even several days. And in one of the examples that we will show you later on, we will show you how we can reduce this time from several weeks or days just to several hours. This approach of time optimization also gives you a benefit when it comes to making some investment decision. Let's say that you're a land manager and you would like to specify, you would like to make a very conscious and quick decision whether to invest in specific land for either building a warehouse, photovoltaic farm, or maybe build a skyscraper. If you would like to make a conscious decision, you would need to make some manual work on your site and calculate the performance of such investment. But with automation, with generative design, this decision can be made quite quickly. And due to the fact that we can iteratively regenerate all these designs, taking into account different factors that we can modify manually, we can also focus not only on making a conscious decision, but also on the optimization part, because through the different iteration and modifying and tweaking the algorithms, we can quite quickly reduce, for instance, the cost of building materials or the cost of the labor. So taking all of that into account, you can wonder whether the generative design will replace the designers itself. Well, I would say quite contrary. I would say that right now we're struggling with the lack of workforce when it comes to the design. It's related with the complexity of the construction. It's related with the time pressure and so on. So the generative design can allow the designers to actually focus on the creative parts of the project instead of the parts which are repetitive, which are pretty tedious. I think that if some of you are the designers, I'm sure that you had the pleasure or unpleasure to verify whether all 40 toilets in some block of flats or in the hospital meet some specific standard criteria. Maybe this doesn't have to be done manually. Maybe this kind of work can be somehow automated, and maybe your work should be focused more on the creative part of the design. So I would say that the generative design in general is something which allows you to focus on the creativity. Well, the designer focus on the creativity, and the rest, repetitive task, can be just automated. So let's maybe show you how we can automate that. But for this part, I would like to hand over the stage to Andrzej. Andrzej, the stage is yours.
Hello. Generally, for the last 15 years, I was working as a software developer. At the beginning, maybe not like a professional software developer because I working in a bridge design office. We design bridges, but it's quite a big company, and one of the team and few people were like dedicated to help different teams, and we start created tools to help them. Generally, when you are not a programmer, we use scripts, use Visual Studio, we use some more not sophisticated tools to do that. But it turned out, even when we not use sophisticated tools, we help a lot of people and we create a special team to do these things. But nowadays we have much more a way to do a generative design, and here I will show you how we can do that. Like the first step is like a script, it's like a Visual Studio. Here is much more popular now, Grasshopper with combination with Rhino, or Dynamo with Revit. Even Grasshopper can be combined with Revit together as well. This is like a pseudo language for programming. We have here blocks which we can combine, and we have like internal some logic for creation some objects, and at the end we can obtain some results. As at the beginning of the presentation, we have some input, we have some logic like in each program, and results. Mostly in Rhino or Dynamo we create some model. Additionally, it's very beneficial here that we can use some library, some programs like statics program, or which we have strength calculation. We can use these libraries here, and we can use it and create model, and additionally calculate internal forces. And in this way, we do not only a drawing, but we can iteratively do a drawings, calculation, and later do once more, and we have project much more. We will do much quicker, and it will be cheaper and much more compatible with a competition on the market, because it's do automatically. Additionally, for these scripts, what is very beneficial that we can use C# and Python, and we have these blocks, and these blocks like have some input. We do some calculation and output, and these blocks also we can create in Python and C#. And this is very beneficial now in these scripts. And when we look at these scripts, it's very nice to use it, but generally it mostly could be used only internally. When we go on the slide back, we can see how complicated it looks like, and it's not so user-friendly when we would like to give it for clients. Then, when we look at in this perspective, some our clients want to some additional user interface, and like here we have like the next step. It's like a dedicated BIM add-ons, and in this way, the most beneficial things here are that this is much more user-friendly. We have some user interface. This plugin can be easily added in a Revit, and any user, any our client, we can give this kind of plugin, can use it, and it will be beneficial for the company, because like here, these add-ons create automatically all the pipes we can define here, like we see a bit longer, and when we here draw a pipe, all the fittings between the pipes are created automatically. Normally in Revit, we have to do it manually and we waste a lot of times of that. When we create something additional like here, everything become automatically. What is very beneficial, that beam of materials are created automatically, and we can in any time see the price of the project, how it will be cost, and because of that our product will be more cheaper, and when it's cheaper, our clients will be more happy about it.
The thing that I think we should stress at these two points that you just mentioned. So creating the scripts with either Dynamo and with Grasshopper. This is actually a good option. Correct me if I'm wrong, Andrzej, but I think that this is a good option for the internal team, which doesn't necessarily have to be aware of how to do the coding, but they know how to do the things, right? So they know how the process looks like. They are able to tweak it somehow. Both Grasshopper and Dynamo provide some ready-made components which you can link together in a form of combining the blocks and with the arrows and streaming down the data from one to another. You mentioned also this fact that if something is still missing, you can add some extra block with a piece of custom code, like either with Python or with C#. But as you mentioned, this is not very convenient solution for the end user, which are not the internal part of the institution. For instance, right now we're working on the Dynamo script project, feasibility study project for one of the manufacturers that is thinking about conviewing and merging together the CAD files from various file formats and merge them together in a form of the combined Revit objects. And we came up with the idea to do that in Dynamo, because they are focusing on Revit in the end. But this is, as you mentioned before, a strictly internal tool. And if they would like to expose these solutions to any, let's say, third parties to make them publicly available, I think that the add-ons are more the way to go, so that you can distribute the add-on, but it has some limitation, I'm guessing, right?
Of course, here is also a quite big problem when somebody do it internally, all maintenance and later support of the code. Because when somebody wrote something in this way, very often later all maintenance or different usage and even reuse the code is more difficult. But still, when we use a Python, for example, or C#, even in these add-ons or in Grasshopper, we can reuse it. When it's wrote in nice way and packaged in the library, you can later reuse it, and it's also quite beneficial. But the next step of all these things, and the biggest minus for add-ons also I can see, which is like a strictly connected with some software, like here a Revit. We can of course move it for AutoCAD, but it's demand much more work, because we have used different API, and it's generally not so easy. That's why the next step of this generative design, and I think it will be like a future of designing, is like some platform which combine and reuse all the programs. And this is like one of this platform. It's a Hyper. Hyper is a cloud platform. That's why it's very easy to give for a client, or we can very easily send for our co-workers or work on the same project even. We can just send him a link, add them access to some project, and we can use it. It works like that we have here a few functions, and it's exactly quite similar to like here, that we have some input in this function, some logic and output. One function can use the other function. And like here, we can see an example of creation of a high-rise building. The truth is that here we can see how it looks like all shape, but all floor here will be redesigned. Oh, here we can see how automatically he create for art facade, and it's how it looks like. It's also nice, and it's like happen automatically. But what it's nicer here, what we do internally, we can design all rooms in the floor, and everything will be divided. There will be all report from that. Then it's pretty useful, and even when here I want to do a bit higher, a bit wider, everything happen automatically, and because of that, the project also could be much better designed, because all design process is very quick. I can just move the mouse that a bit shorter, and I can see how it looks like, and I can even have seen bill of materials or the cost of the project. This is very beneficial. And
what can I add to this topic? Because we're talking about the Obayashi. I'm not sure whether you heard about this company. They are actually coming from Japan, and we all know what are the restriction when it comes to the construction in Japan. You know, the earthquake and so on. So they actually working in the real estate business for a while, for several decades. They are both buying the land, building the steel towers, either selling it or commercializing. And actually, they had this issue that they wanted to actually reduce the process of making the decision and making the design itself. And they all knew exactly how the whole process should look like. They know the algorithm in their brain. It was repetitive algorithm, and the only problem was that it was time consuming. They just wanted to make it shorter. Just want to make it a blink of an eye. Of course, there are some corner cases for each and every case that somehow needs to be addressed, but I think that I will leave that part for the next section of this lecture. But in general, they were able to reduce the time of making the decision for the investment. They reduced the time of preparing the project from weeks to hours.
Yeah, and what is more important, that in this situation, the designer can think on things which matters. That means he don't want to think how to do it because he have a deadline and he really have to do it like fast, and they don't have to think about like more important things, because he don't waste of time for a lot of time consuming things. Additionally, this platform have like built-in libraries, like for 3D design, calculation, all like moving clients or different things. We don't have to invent a wheel. We have to just reuse a libraries which have. It's like quite similar, like in Python. We have very nice libraries. That's why everybody wants to use Python. Here we also quite a lot of libraries. That's why we don't have to redesign things and waste time for that. When we look at like the most advantages I already said about it, that is this like accelerating design decision making, even under the design, and that decision making, because very often we make decision for some results. When we do it manually, we can design it once and we have to make a decision. We can redesign, but we are not afford to redesign 3 times, for example. Here we can redesign 50 times. We can just move a few things and our project will be cheaper and more competitive with different software. What is also very nice in the Hyper, that this can combine a lot of software which we are using now, that like CAD, Revit, all images, all like when we have some template, when we have some Excel spreadsheet, when we also have some input, output, we can easily like import it to Hyper. We're telling that here we put input, here we have output, and all logic which we create in the past, and we don't want to rewrite it for the Hyper or in C# or any different language, we can reuse. Rhino is also. Then here in Hyper, the process of designing looks like that we can extract some results or even function from some programs which are used in the past. We do some modification and we can export it. But it's not like we always do like that. Sometimes we even do a creation because we can put input in Hyper. You can present it nicely. But sometimes when we would like to import some things, it's possible. And when we like to export our drawings, our 3D things to CAD, Revit, or different programs, very often, for example, like we work with a client, for example, they want to have drawings in AutoCAD or he wants to in Revit, then we can export and show him exactly what he wants. As a good example, for example, here is like we can combine Grasshopper. In Grasshopper, for example, when somebody creates some logic and have some that we have some input, do some logic and output, we can easily take all this logic to Hyper. We can just have to download in Grasshopper some plugin. We tell that this function we want to have in Hyper. We select what is input, what is output, and the function will be created. Then we reuse what we have already done.
I think that this is also a good case when it comes to improving the usability of the scripts from Dynamo and Grasshopper, because one of the main issues that you might face with such automations is that it's not very wisely to distribute them to external audience. And if we can wrap it in a form of the Hyper library and put some nice user interface on top of that, which allows the end user to utilize it in a more user-friendly way, then we can somehow also try to, from one perspective, reutilize the automation that we already have in place, and in other case, make them eliminate the biggest showstopper that we might be facing with such technologies, which is the user experience problems, isn't it?
Yeah, exactly. And here the next slide show us very nice thing, which I think is unique when we look at different wizards, because we can create a lot of wizard for creation, all like I in the past create a model, all bridge model in the software for static calculation. But what is the most annoying? When I have to redesign a little bit, because like here, for example, everything was generated automatically and we have support and we have to move it a little bit. But our generative code doesn't support that. And what we can do? In most of these cases, we generate the model, for example, in Revit, doesn't matter in which program, and later manually move it. But what happens when we have to redesign it because some things change? For example, the height of the building is different. We have two options: do it manually for the project what we have, or we again use a wizard to again redesign our structure. But again, this small change we have to apply manually, which is very time consuming. Hyper give us an option like they name it override. It means that after creation of the model, like here, we create a model. After of a creation model, we tell that, for example, this support should be shorter, longer, or doesn't matter. Why we have to do it manually? Because our main global algorithm don't handle it. Sometimes it's too complicated, or even it's not worth to do that to handle 100% of cases. We handle 95% of cases. But later, using these overrides, we move it. And when we have some change in the project, we generate automatically, but this override, it's safe, that it's moved automatically for us. And it's very, very useful, because later when we want to redesign, we don't have to do it from, we have to use our wizard and do it from scratch, as I name it, because we have to use our wizard and apply these changes, or the project which we have to again modify it to match them. It will be very, very flexible.
The thing is here with the complexity of the algorithm, right? So sometimes it doesn't make sense to make the algorithm too complex. It's just easier to make the algorithm maintainable, because some corner cases might not be worth implementing, because that might both increase the complexity of the algorithm, and then also increase the complexity of the configuration, which for the typical use cases might be too complex to work with. But if we, as you say, we're working with this overrides, this is something which is called the augmented design. So we're generating design, then we're augmenting what is generated, and if we need to do this next iteration of regenerating, all this augmentation aspect remains, so we don't have to augment it once again, right? That's what we had in mind.
And yes, and it's very unique, the truth is, because when we look at different wizards, they don't have these tools, and this is like, because of that, very often the user interface also will be much easier, because we, in normal cases, want to cover as many possible situations to handle 90, but it's never 100%. Always after regeneration, we have to change something. And in this situation, we have to we save really a lot of time because of that.
Andrzej, you said that I said at the beginning that we also wanted to show some examples, not only from the design perspective, but also from the manufacturer perspective, to prepare the offering. Could you actually maybe show some example from this section?
Okay, then this is here. This is like we do for a client a drainage system. This is siphonic, and there is a lot of also hydraulic calculation. And this also can show us how we create a model. Here, the model in the presentation is shown how we created directly in Hyper. But all these things very often are already in Revit. Then we can just take a Revit model, and we have some converters. When we converted this, and it's like extracted automatically. This is very nice as well.
So we can import directly from Revit. Can we import the data, the project from other systems as well?
For now it's Revit, but we can also do from AutoCAD pretty easy in the same way. But here a client wants Revit, because most of people in this drainage system use Revit, and they need it. What is here very nice, that all drainage system is generated automatic. We have to, of course, add some things, like here. When we do it manually, we create access of drainage system, like we can see. And additionally, we can have some properties. All regions are like created automatically, or like roof segment have a different rain intensity, or different, we have really a lot of parameters. It's like, and also these parameters depends on the country. Here we have projects information, and in project information we defined a country. Then all this calculation will be done according to design standards of countries, and sometimes even when you select different countries, have different parameters. Oh, here we also can see interesting things. In most cases, we don't have any conflict with pipe. Here I have shown specially the project that we can have this conflict, but also we can, as you can see, we can very easily manually just move the pipe, and we solve these conflicts. And what is very nice, Oh, and here, for example, it's the next things. When we put some, for example, column here, all the system is generated automatically, and it's move around the obstacles. What is very nice, I stop here, that we have this number 73424. This is price index of this project. Then when we do all modification, we always see a price. This is not a price, but price index, because the client don't want to show the price because everybody have different prices, but it's like an index which show us if the project will be more difficult, more expensive or not. Also, this price index combine like labor factor, which also it depends on the country. For example, in some countries, the labor is much cheaper than some materials and some not. That's why here it's a division. But what is nice that we don't have here all big beam of materials. We can see only one number, and pretty easily we can do like or iteration for the designing, and we have the smallest number as possible, and we know the project is the cheapest for the client. What is here nice additionally, when we go out the end, that we generate this model, and for example here the roof height of the roof is very important because the pressure change, and here when at the end I move a little bit a roof, normally everything change, all pressure are changed or diameter of pipes are changed, and additionally all obstacles which are overrides, it's not like automatically generated, are also applied here, and everything is recalculated. Then all changes are done automatically.
So long story short, Andrzej, maybe let's just, I will ask you a question. Why actually the manufacturer wanted to create such a solution? Why they actually need to have this automation in the drainage design? Isn't that the case that it's the clients that actually plan the drainage? The manufacturer wants to only sell the products, isn't it?
Yeah, but there are, I think, a few factors. One, like here, we can see that here additionally, I will move back a little bit. Here we can see all bracketing additionally is generated also additionally. And at the end, we also export for Revit and Boom of Materials. And why we need it? We need it in two cases. For example, when we would like to show, for example, offer, and we even don't know if we win or not, we can do an offer very quick and very precise. Then we can win some contracts. And this is very nice. And additionally, this software can be used for different user. We can extend and give for anybody because it's not like a plugin or external use. It's a cloud platform and anybody can use it very easily.
But if I'm using Revit and I need to have this design that we generate in Hyper in Revit, can I smoothly move it to Revit without any issues?
Without any problem. At the beginning, even when we have in Revit all the geometry, we can import at the beginning for our program, do all the calculation, do reports, price, everything. And even when at the end we want to show in Revit again, we also export to Revit. It's not a problem. In most cases,
and we can also generate the bill of materials so that for the sales process offer preparation, we can just have a ready-made proposal for the client.
Exactly. And additionally, we have all calculation, pressure calculations also. It's not like a black box. Of course, in Hyper, everything depends on the client and what to do, what we want to do. We can also show a presentation. We can do additional report. Like it's strongly dedicated tools for the clients. It's not like something, because we have very often general rules for everything. This is dedicated tools for our client, and it's because of that I think it's exactly what he wants, because sometimes when something is for everything is not exactly what we need. This is exactly what the user our client wants. Additionally, what I like in Hyper, that he developed really a lot. When, for example, here we can see like we have artificial intelligence. Generally, we just type and they recently create. For now, when I look, I just play around with that. It's like nice things to have and to look how it works. But generally, I write something and he extracts these things and create a model.
Probably yeah, natural language processing.
Yeah.
It's just a matter of parsing the natural language, converting it into a hyper command, and
yeah, and probably it's like a future, but it's a question how is it will be now or in a few years, 10 years. But when we look how it's developed now, probably it could be quicker than we think.
What I can say here is that when it comes to hyper and the manufacturer side, this is also I know it from our own experience. It can also be an upselling and cross-selling option, because, for instance, right now we're talking with the prefabricate manufacturer, and there's this idea of prefabricating the model in order to prepare the offering. And I know that the idea would be also not only to sell what the client wants to sell, but due to the fact that manufacturer might offer other things which are available within the project, which were not requested by the customer, but they can be easily included into prefabricated generative design. This gives the possibility to the sales rep to actually cross-sell other products with just a blink of an eye, because they have the proposal ready anyway. So the sales perspective and proposal preparation when it comes to generative design, I think that might be a very huge key factor, especially for the manufacturers.
It's also a question of risk. When we prepare an offer and it's not a detailed offer, we have to put some buffer for the price, because we are not sure, the calculation are not sure. It's a preliminary calculation. And here, when we know that it's a detailed calculation and we exactly have a project, we have put very precise an offer. This is very good. And generally also this offer looks completely different, because when you give for a client offer which have all the details, it looks completely different when we put some offer and we put some approximate things. I mean, it's also, but that's why generative design is developing so fast, I think.
Yeah, I think that we should summarize more like the strategies. So as you've seen before, we were talking about the three approaches when it comes to automating to make the automation of the design. We're talking about the scripts. We put Grasshopper and Dynamo on the table. As you've heard, it's more for the proof of concept or for the simple automation, although you can extend it with the custom logic of written in C# of Python. But definitely this is rather an internal rather than the tool for the external audience. If you would like to move more into the better publicly available solutions and better distribution of the solutions for the external user, probably you should focus on the solutions like the BIM add-ons, like the one that we showed you previously. This is actually the add-on of one of our customers that is based on the BIM Streamer Revit module, which can be quite easy customized for each and every client. But if you don't want to force anyone to install any software, if you would like to allow the access to your application quite easily, if you care about the security, sometimes maybe you care about the algorithms that are included within either the scripts or BIM add-on, which can be potentially decompiled, or you changing them quite constantly, and you don't want to force anyone to reinstall the solutions all the time or be limited to any particular software, then the solutions which are available through the web browser, through through the internet, directly through the internet, might be the way to go for you. And in that case, I think that the best option would be to work with the solution similar to a Hyper platform. If there are any questions related to either generative design or any of the strategies that we were talking about, right now this is the best moment to ask. I would, in taking the occasion, I would also like to mention that we are actually talking about, we are actually the official partner of Hyper. So if you're thinking about doing any automation related to either Hyper, Dynamo scripts, Grasshopper scripts, or Beam add-ons, feel free to give us a shout. I would like to thank you all for joining. Thank you, Andrzej, for your insight. I see that there are no further questions, so I think that we can close the meeting. In case you would like to reach out to me, just take a screenshot of this photo and write me back directly. Thank you very much.
Thank you.